Hey and welcome back to the channel. Today we're going to talk about positive bus bars and why I am not a fan of this one. In the video I'll show you two better alternatives, and at the end we'll talk about a price comparison between the three bus bars I'm about to show you. So the bus bar, that is the place where all your electrical devices come together. You need a negative bus bar and a positive bus bar, and from these places where all your devices are connected together, you will put a wire to the battery. To ensure your cables are protected, you need to add fuses. And with the individual bus bar, it looks like this. Here we have a DC-DC charger, and it's connected to the bus bar via a Midi fuse. Please never use cheap breakers like this one, because they are just very bad. Use high quality fuses, preferred Midi, Mega, T-Class or MRBF from brands like Victron, Blue Sea, Little Fuse or Hella. That being said, to add a fuse with the individual bus bar, you need to cut your cable in half and place two lugs to connect to your fuse. And at this point I often see people make the same mistake. People don't know how to crimp a lug. They use the wrong size lugs on the wires, or they buy very cheap lugs from Amazon, for example. They are very thin and they don't conduct very good. And this can create dangerous situations, because if you make a bad crimp, the energy cannot flow directly to or from your device, and it creates resistance, and that resistance that creates heat. So each extra lug you have to place is an extra opportunity to create a failure. So a basic electrical installation most of the time has at least 4 electrical components, like a DC-DC charger, a solar charge controller, a 12-volt fuse box and an inverter. And that means when you use an individual bus bar like this, you need to crimp 4 times 2 is 8 extra lugs. So that gives you 8 extra failure points, so to say. Besides, the individual bus bar and separate fuses also take up quite a lot of space. So instead of using a positive bus bar, I have a better alternative, and I'm going to show it to you now, but first I need to redo some things. So this is the first alternative, and this is called a Midi Mega fuse holder. And with this you can directly place your lugs onto the fuse without cutting your cables in half and adding extra connections. You would still need, of course, a negative bus bar to connect your negative lugs, and as you can see, this is also way more compact than the individual bus bar with separate fuses. So using this Midi Mega fuse holder, in my opinion, gives way less chances of failures, because you don't have to cut your cable in half and place the extra lugs. Personally, I've used this Midi Mega fuse holder in 2 of my camper vans, and I would recommend this one to anyone who doesn't have a very extensive electrical system. It's perfect to connect, for example, the DC-DC charger, your solar panel charger and your 12-volt fuse box. Also, there is a mega fuse here at the bottom where you can connect your inverter to. And talking about the inverters, if you want to run an inverter with 2000 watts or bigger, I would not recommend this one, but I would recommend this fuse bar behind me. So this device behind me here is called a Lynx distributor or a power in. Personally, I have a power in. It's a bit cheaper and I don't need the lights to be showing me which fuses are blown. This bus bar is rated for 1000 amps. It's really solid build quality, and it's perfect if you want to build a more extensive electrical system. You can connect multiple Lynx devices and connect them together, for example a Lynx power in, a Lynx shunt or a Lynx BMS. You can build a whole system like this. So the Lynx distributor almost works the same as the Midi Mega fuse holder. You can connect the lugs directly onto the fuse points without cutting your cables in half again. One more thing about this Lynx distributor, you don't need a negative bus bar. This one is already integrated here, and the cables are behind the positive cables. So this creates a really solid and compact bus bar. So if you have a big electrical system with a big inverter, I'd recommend the Lynx distributor or power in. If you have a smaller system, I would recommend the Midi Mega fuse holder. And before we are going to dive into the price differences, I just want to let you know that if you are building your off-grid electrical system and you need help with the design of it, you should definitely check out our software. You can create clear wiring diagrams. The wires and fuses are automatically calculated. It works with 24 volt, 12 volt, 120 volt AC, 230 to 40 volt AC, and you can use both busbars, both this Midi Mega fuse holder and the Lynx distributor. If you want to know more about the possibilities, please check the link in the description below this video. Alright, now let's see what each scenario costs. On average, a build has 4 devices connected, an MPPT, a DC-DC charger, a fuse box and an inverter. And based on these devices, I created a very small calculation. So for the individual busbar, you would need a positive and a negative busbar. I've chosen 2 Victron busbars. You would need 3 Midi fuses, 3 Midi fuse holders, 1 mega fuse, 1 mega fuse holder, and 12 cable lugs. This would total around 180 pounds or $250. Then the Midi Mega fuse holder. You would need a Midi Mega fuse holder, a negative busbar, 3 Midi fuses, 1 mega fuse, and 4 cable lugs. This totals around 101 pounds or $140. And now for the Lynx distributor. You can also use a Lynx power in, as I have done. The power in is around $60 cheaper than the Lynx distributor. So for this calculation I used a Lynx power in. You need 4 mega fuses and 4 cable lugs. That totals around 188 pounds or $260. So the Lynx power in is almost as expensive as the individual busbar. The Midi Mega fuse holder is the cheapest choice. Let me know what your choice is and why. That's it for this video. If you have any questions or want to share your thoughts, feel free to leave them in the comments below. If you want to learn more about off-grid electrics, you can download our 92-page ebook for free. It covers almost everything you need to get started. You'll find the link in the description. Thanks for watching and see you in the next one.